Good afternoon. This is Mr. Nyati, and like I said, that I will answer the first 5 questions. I'll be looking at them in details, and I will also give the answers exactly the way they are supposed to be, and also try to explain why some options are not necessarily supposed to be opted for as answers. And so from your question, I'm sure from that paper it says, the first question says, which of the following is an example of the application of chemistry at home? Which of the following is an example of the application of chemistry at home? Now, in this question, your aim is to look at something that is applicable home. Now, you need to understand chemistry. Chemistry, like we said last time, is basically the study of matter and the interactions of matter, with heat, and how it changes from one state to another, and other things. And so you need to look at it from that point of view. At what point do you use chemistry when you are at home? Is it when you use an amplifier in a radio? That is when basically you want to attract a large crowd, and that option is basically applied to physics, which is A. A says the use of amplifiers in a radio. B says the use of cosmetics. Now, cosmetics, what are they? Cosmetics, I'm sure things to do with the amafta, and it says the use, not the production, but the use. Amafta kunganda. Is it not home where you use those cosmetics? Oh yes, it is. C says production of ammonia in the Haber process. Now, that is very industrial, production of ammonia is basically industrial. D says industrial production of alcohol. It even says breweries ni kunganda. No, it's industry. So the answer is B for question 1. The answer is what? B, because at home, that is why you use the chemistry of what? Applying cosmetics to your body. You know how much you need to apply. That is basically chemistry. If there was cooking, you would have also chosen cooking, because cooking you apply chemistry at home. Question 2 says the best apparatus that is used to accurately measure a required fixed volume of a reagent during titration is, the answer is pipette. B. Question 2, B. Because the question says accurately measure. Now, a pipette or a pipette, others will call it a pipette, is that thing where you put in which you put in your mouth when you want to put in a mixture, or you want to have an accurately measured volume of a reagent. You use a pipette, you put it in your mouth. Kamonika kwati nika pipe, so kari kwa takari lemba no kulemba 25, it is written 25 cubic centimeters. That is accurate. It's a fixed volume, okay? It's a fixed volume. So it is B. Now, why not bigger? A beaker is, you don't measure a fixed volume using a beaker. What about a measuring cylinder? Just the same as a beaker, you don't measure a fixed volume, okay? And it's not even accurate, okay? What about the burette? A burette, you only use it when you are titrating. You are doing the process of titration. So the only one you can opt for is a pipette, which you use to measure or accurately measure a required fixed volume of a reagent during the process of what? Titration. Thank you. Question 3. Question 3 says the best method to separate a mixture of sand and diesel is. Now, let me just try to explain these 3 processes before we go to the answers. Not 3 processes, but these other processes. Decantation is whereby you have a solution, a liquid, and some solid. Now, that solid must be able to settle down then you decant. For example, the best one is pieces of chalk. Pieces of chalk settle down to extents where even if you decant, they can't follow the flow of water. Okay, then when you go to the other one is distillation. Distillation is basically the separation of a pure liquid from a solution. Okay, that one is out. Decantation, distillation, out. What about evaporation? Evaporation, this is where you are separating a soluble solid from a liquid, or a liquid from a soluble solid, where you evaporate the liquid, then the solid remains. For example, ngati shower, you know that thing whereby you pour after showers up, then you pour water containing salt, which is salt solution, you pour into the pan, you see water evaporating, then the salt remains white. That is evaporation. But can you use it to separate diesel and sand? No. What about filtration? Now, filtration is the process of separating an insoluble solid from a liquid. Now, there are two things here: insoluble solid and a liquid. It doesn't matter which liquid. It can be water, it can be diesel itself, it can be milk, it can be any liquid. Okay, and then the insoluble solid, it doesn't matter. Gravel, okay, it can be sand. So this process qualifies. So the answer for number 3, it's what's the answer? The answer is D. Question 4 says identify an inert gas. An inert gas is basically a noble gas. Okay, those that are found in group 8. Okay, those that do not react, and they have the same type of atoms. They don't combine with any other atom. So if you look at that question, you find that between ama dots inatu chitawati ni ring ni pachupo. The others are black, the others are white mixed together, the others again black and white, you know, mingled together as if chupo. Then the C one, the one in C, it's just unique, it's itself. So you opt for what? For C. Question 5 says the following equation is incomplete. Now complete it. It's lithium oxide plus sulfuric acid. Now I'm sure how do I know that this is lithium oxide? Not lithium oxide, no, but lithium hydroxide plus sulfuric acid. Now there's a topic called the acids and bases. Okay, acids and bases. One of the chemical characteristics of acids is that acids react with the bases to form or produce salt and water only. Now this one is a what? Lithium hydroxide is a base. This one is an acid. So what you expect this side is what? A salt plus water. Water. These are the things that you expect. So to rewrite this equation, we'll have lithium hydroxide plus sulfuric acid to give us. Now, how do they produce? How does it produce? How does a salt get produced out of this reaction? What you should know is that when you have something like this one will combine with this one on the product side. Then this one will combine with this one on the product side. So these are what we call reactants. Then this side you have the what? Products. So you have lithium and sulfate. Lithium, sulfate. Now you know that sulfur, a sulfate, lithium has a valence of 1, sulfate has a valence of 2. So to make a compound, this one will come here, this one will come here. So you have lithium sulfate, like that's like a 2 here. So this is what we are going to have here. Plus the other product will be what? Where is that one? It will be water. So we'll have H2O. But ensure that your equation is what? Is balanced. Now they had written a 2 here, meaning that it should be balanced this side. You have a 2 here for lithium. What about oxygen? How many do you have for oxygen? There is 1, 5. Okay, so I mean this one is 2, so making it 2 plus 4, it's it's 6. What about this side? You have 4 plus 1, 5. It's not balancing up. What if you add the 2 here? So you have 2 lithium, 2 lithium. Oxygen, 2 plus 4, 6. Oxygen, 4 plus 2, that is 6. Hydrogen, 2 plus 2, 4. Hydrogen, 4. So it's balanced. By the way, how do we balance the chemical equations? You know, chemical equations, for example, the one that we had, you line up them like this: lithium, oxygen, hydrogen, sulfur, yeah, something like that. So this is the reactants. This one is the products. Okay. Yeah, I was just waiting for this. Lithium, oxygen, hydrogen, sulfur. So you check from your equation. How many lithium do we have? Lithium atoms 2. Oxygen atoms, you add all of them on the reactant side. You find that initially they were 5. Hydrogen atoms, you have 4. Sulfur atoms, you have 1. This side we had 2. Oxygen we had 5. No, oxygen this side was 6. Oxygen this side was 6 because of the 2 there. So what about oxygen this side? 5. So when you reach here, you should ask yourself, what should I do for me to have 5? So you need to look for where you should add the 2. On water, when you add the 2, oxygen becomes 6. Then when you have oxygen 6, hydrogen becomes 4, sulfur 1. Then the equation is what? It's said to be what? To be balanced. Okay, this is the end. I know it has not been perfectly done, but I hope it will be helpful. Thank you so much. Bye bye.